an all-new series on blockchain, a buzzword for everyone. Let us know more about it from Irfan Khan, who is a digital economist and is the founder of Hypermind, which is a tech and research company that uses blockchain and AI to create secure digital economies. Before I hand over to Irfan, two more things from my side. Ask questions at any time during the session. Irfan will answer to most of them, keeping the time limit of 60 minutes of webinar in mind at the end of the session. Please leave your feedback to help me better my future episodes. So now over to you, Irfan.
Thanks, Ankita. Hi, everybody. Good afternoon. So this topic of blockchain, it's been around for a while. It's a huge topic. I will try to fit in this massive behemoth in 30 minutes. I don't know how I'm going to do it, but we'll figure it out. If you have any questions along the way, please stop me. Just to set the expectations, this is not a technical session. We are going to be discussing what blockchain essentially does, the bigger picture, what the main problem, the core problem that blockchain is attempting to solve. And in future sessions, we can probably move on to a more industry sort of specific approach where we can dig deeper into specific requirements. But it's really important to understand the power of this phenomenon, that what we are referring to as blockchain today, right? So to understand this technology, I think we will have to go back. We will have to go back into history and try and understand what and where it's coming from. What is the source? What is the thought? What is the process that has led to the evolution of this technology that we refer to as blockchain today? All right. So the agenda will essentially be myself. So I'm looking after this presentation today. I'm Irfan. I head Hypermind. We are currently doing a lot of research into decentralization. And what decentralization is, we will talk about that. We will also discuss blockchains. We will discuss the role of cryptocurrencies. We will discuss real-life blockchains. We will discuss the blockchain and governments. What is the engagement there? And we'll have a quick Q&A at the end. So let's. I'm guessing everyone knows what this is, but for those who are not aware of what this was a tool which we grew up using in the late 80s, early 90s, essentially a fax modem. Now, this fax modem was painfully slow. As you can see, it says 14.400 kbps, which was...
Irfan, I'm so sorry to interrupt. Can you make your screen like a slide share?
What does that mean, slide share?
I mean like a full screen.
It is full screen.
Okay.
No?
Okay. Now it is. Yeah. Now please proceed. I'm so sorry to interrupt in the middle.
Can everyone see the slides now? Okay, cool. So what? So we will discuss introduction. We will discuss decentralization. We will talk about how blockchains are helping with this. We will discuss the role of cryptocurrency. We will discuss real-life blockchains and how governments are getting involved with this. Right. So for those of you who are not familiar with this, it's essentially a fax modem. It was how people connected to the internet back in the day when there was no internet. We would have a peer-to-peer connection where we would dial up 14.4 kbps, extremely painfully slow. It would take about an hour and a half to download one image. But what we probably didn't realize is how important this little tool would be today in our lives in terms of the internet. So in the 80s and the 90s, we had one-way internet, right? So you would probably just log on to a website and just read information, and there was just like one-way information flow, which was the foundation of how the internet was formed. About 10 years down the line, we moved into Internet 2.0, which sort of helped us solve a lot of problems, right? So search being the first problem, that we were now able to find things on the internet. We were able to find people. We were able to find places. And of course, Google has managed to, and now Bing and so on have really nailed this problem. we are able to now identify and find things that we need very quickly. Another problem the internet solved for us was to connect with each other. So now we can connect with people, with places, with businesses, with so connectivity is now, of course, with IoT coming in. So we're basically connecting everything over the internet. A third problem that was solved by the internet was communication. So of course now with Facebook and WhatsApp and what have you, all these companies are around and all these tools are around, Viber, you are able to communicate with each other. A fourth problem that the internet solved for us was distribution. We are able to distribute products, things, information, mass distribution of everything and anything that we can think of. But although the internet solved a lot of problems for us, there were some things that the internet was not able to fix, and primarily is trust. The internet was not able to solve the problem of trust. We don't trust anybody on the internet. We don't know where information is going. We don't know where information is coming from. Although Wikipedia has a lot of content on it, we're not really sure if that content is verifiable. How long has it been on there? When has it last been updated? There are a lot of questions around trust. Another problem with the internet is it's not transparent. So we don't know what is actually happening in the background. Where is your data being stored? Where is the information going? Where is it coming from? Transparency is a huge problem on the internet. And the biggest problem that the internet created for us was intermediaries. Now, please understand that the whole idea of the internet back in the 60s and 70s when it started out was never meant to be a massive entity sitting in the middle and trying to govern things, right? So you have banks, governments, and corporations dealing on a daily basis with our data, with our information, with our money, and they basically control how we are operating and governing in our daily lives. So let's take some practical examples. So everyone knows the Google and Facebook story. It's not something new. I mean, we're all familiar with this. The point of the matter is that we've allowed them to do that. We are personally giving away our information to them. Demonetization, although it's not a political discussion, but it was still painful to believe that there was one person who was able to take such a big decision in this country. Another classic example is Maduro, who is the president of Venezuela. He went, as everyone knows, Venezuela is in crisis at this point. He went to the Bank of England for his $1.2 billion of gold, and the Bank of England just turned him down. If you go back a few years into the Arab uprising in Egypt, when you had millions and millions of people protesting in Tahrir Square, they just shut down the internet. And when it's not really it's a civil unrest, so why would you shut down the internet? And people want to communicate with their families, they want to know they're fine. So my main concern is who has given these people this level of authority to take these decisions that impact millions and millions of lives, can be shifted in a day, in 1 hour, in one split second, and there is no hope. There is no hope to turn this thing around. But there is a way out. There is a way out, and it doesn't have to be this way. It doesn't have to be this way that we have to suffer in silence and not being able to take back the rights and our privacy and our information that we've lost.
Irfan, the slides are not moving. I'm so sorry. Slides are not moving. No.
So which slide are you on right now?
I'm at the fourth one.
What's written on it?
Internet 1.0, 1990 to 2000.
Is it not refreshing now?
No. Not an issue. You can close it and again, like.
No? Okay, hang on.
Yeah.
Is that better?
No, it's a blank screen. Nothing over here. I'm so sorry, all of you. Just please hang on for a few seconds. Irfan is working on it.
Can you see now?
Yeah, this is the first slide. Yeah, now it's full slide. Yeah, it's changing.
Changing now?
Mm-hmm. Yep.
Okay.
Yep. Now it's fine.
Okay, so we'll
Perfect.
just quickly go back. So the internet solved all problems for us, starting from search. We were able to find information. We were able to connect with each other. We were able to communicate with each other, and we were able to distribute information and things. But the internet was not able to solve issues around trust. We don't understand. We don't know who is dealing, who is posting information, and where information is coming from. We also don't have transparency on the internet. So when we have all these cloud services and we have all our payment gateways happening, where is your money coming? Where is your money going? There's a huge problem with transparency on the internet and intermediaries. So this is the core problem of the internet today, that you have companies like Google, Facebook, and huge governments and corporations who are not basically um, working in the interest of their customers, right? So we all know the Google and Facebook story, Cambridge Analytica, how they are manipulating our data. Demonetization was a huge problem with us. One person taking a decision like this is just mind-blowing for me. Maduro, the president of Venezuela, he goes to the Bank of England to get his money out, $1.2 billion of gold from the Bank of England, and everyone knows what a problem Venezuela is in, and the Bank of England just turned him down. And the last but not the least, of course, is Tahrir Square in Egypt. When the Arab uprising happened, they shut off the internet. And so one person taking these sort of decisions, or one entity taking these sort of decisions affecting millions and millions of lives, whether positively or negatively, is not something which is acceptable moving forward. So the whole issue is, how do we change this? How do we address this problem? So power, of course, it tends to corrupt, but it's not their fault, right? It's not the issue of the people. It's that they have managed to gather this power that we now have to what we call decentralize. So the decentralization of power. So taking a step back, I urge you all to go and do your homework on Paul Baran. He was an engineer and a scientist. He was probably the first person to write a paper on decentralization. He was tasked by his government in the US at the peak of the Cold War between Russia and the US in the 60s to create a network that would survive even in the attempt of a physical attack, right? So even if a bomb or anything else attacked the network, it would still survive. And he basically wrote a paper called the Survivable Communication System. I can share that with you or with Ankita, and she can give that. Please read it. It's very interesting. And I believe that the answer to all those problems lies in this space where Paul Baran actually came out. Rand Corporation, for those who are not aware, is basically the company from the 40s and the 50s that laid out the foundation of work culture in terms of Google, Facebook. All these big tech companies follow the same creative culture that Rand Corporation had set back in the day. So decentralization essentially, and I can talk about this forever, but we're not going to go into this topic because it's branching off into a stream, is divided into three main sections: infrastructure, architectural, policy, political, and management of that infrastructure. So dividing any organization into these three segments of decentralization means, how do we make sure that the infrastructure is available at all times, even though it's broken or attacked? How do we make sure that the policy is always made by no single authority and always decision making is done in a collective? And management, how do we manage multiple decision making and support of that network? So let's not go into this. We'll branch off here. Please mind you, I haven't discussed blockchain as yet, right? So this is something you will see very frequently in presentations, where on the left side here, we have a centralized sort of network. So you have today all these big corporations that have these centralized silos of data and information and management, and everything is done from one central area. In the middle, you have distributed, where you do have certain edge computing and processes and cloud computing and fog computing, where processing and storage of information is not just centralized, it's distributed in many places. But the issue with distributed is that the management and policy is still happening from a centralized entity, from one person, right? Our objective is to reach the space on the right, decentralized. Decentralized essentially meaning no one place of storage, no one person managing, and no one creator of policy that is basically running the whole show. So it's basically democratizing everything that is available to us in terms of decision making and management. Right. So I'm sure you all have. So now we'll start talking about blockchain, right? So you have to think about how this actually affects how this phenomenon. I'm not even going to call it technology. It's a phenomenon, right? It's decentralization has been a core thought. That's been a movement ever since the beginning of the internet, ever since the beginning of tech. Everything is going digital. Everything. So why not the economy? Even the economy will eventually become digital. Now, imagining blockchain is it's a tricky scenario because yes, it's a computer, but it's slightly different in the sense that you have a lot of hardware which is similar to the regular computers, and you have millions and millions of devices that are available today. So if all of you are, there are about 180 attendees here, I'm sure between the 180 attendees, there are at least 180 computers available today. So what I mean by computers is handsets, laptops, phones. Probably you've got families at home, and each family member has their own phone, each family member has their own laptop, each family member has their own, and even companies involved now have servers. So there are millions and millions of devices out there. And all of those devices are present on multiple operating systems. So Android, Linux, OS X, Ubuntu, Windows, what have you. So what I want you to imagine now is that we remove all of these operating systems. So we remove Android, we remove Linux, we remove Apple, we remove Ubuntu, we remove Windows. And instead of keeping individual computers at home, we build towards one world supercomputer. So what does that mean? That essentially means that every person, and I will go back, every person that adds a computer, adds a piece of hardware, adds a piece of RAM, adds a piece of screen, is feeding into not one individual computer, but one world supercomputer. So everyone who is getting on the network is adding to one big computer, which is owned by everybody and nobody at the same time. I'm hoping that this is something you understand, you grasp very clearly in your mind. That we are not discussing blockchain, we are discussing a computer that is distributed across the globe, across the world, and everyone owns a small piece of hardware. So even if half a country burns down to the ground in war, the other half of the computer still exists. The other half of the data still exists. So this is what and how you should be imagining blockchain. Now, once you have your one world supercomputer, you need logic, you need software, you need basic set of rules and regulations to ensure that this one world supercomputer is functioning the way it should be functioning. It has to be secure. It should not be hacked. It should be immutable. People should not be able to go on like we can log on to our own personal computers today and make whatever changes we want. This should not be possible because it doesn't belong to one person. It should be decentralized. Not one person can manage it. Not one person can own it. It has to be distributed. It has to be having all data and management available all the time, everywhere, 24/7. Smart contracts, they're essentially basically sets of logic rules that is promising a user that this is going to do what it is promising it's going to do. Consensus is essentially how do you undertake decision making in an environment where everyone is right. How do you manage that? That is consensus. It's peer-to-peer, no more centralized entities. If you have to send money from A to B, you send money only A to B. It has got nothing to do with any banks in between. It's got to be transparent. Everyone knows where the information is coming from and where it's going. And if it needs to be encrypted, we can go ahead and encrypt that. So essentially, the blockchain is an operating system, and you have to understand this analogy. It's an operating system for the one world supercomputer. So of course, we've all seen Ledger, what this is. So when you have something like a one world supercomputer with it has to keep a record. It has to keep logging all transactions, because there are millions and millions of transactions happening on this supercomputer every second. And it has to be recorded that in a chronological order that all these events are being recorded. So when you have a one world supercomputer, you have an operating system for that one world supercomputer. You need to bring some level of global logic to it. So when we talk about all these fancy things that blockchain has, like distributed ledgers, smart contracts, token economics, game theory, consensus, cryptography, what is it? What does it mean? How does it all tie into? So what it essentially is talking about is, how do you get this one world supercomputer to behave in a certain way? Distributed ledger is a concept which has been existing with us in time immemorial. Whether you go to the Greeks, the ancient Romans, everyone used ledgers to keep a balance of what was coming in and what was going out. Whether it's financial, whether it's logistical, whether it's management, whatever it is, they all use ledgers. We are now bringing the same concept digital. Smart contracts, governance. How do you ensure that when something is promised by this one world supercomputer, it's going to happen? Token economics. Economics is an ancient study. It's been going on since forever. We are now bringing economics into, and we will go into the token aspect of it a little bit later and why it's there and how it works. So we are bringing economics into this one world supercomputer, because now you have economies that are present in the supercomputer. There are people who are transacting money. There are people who are sending products. There are people who are talking. There is a lot of, it's basically the economy being transferred to the digital side. Game theory, behavioral psychology. How do you get people to react in a certain way? Why would you support this one world supercomputer? What do you need to do to help this? How do you remain motivated? Why will you go out of your way to go ahead and maintain this computer? So game theory is involved to motivate people to behave in a certain way to ensure that you are maintaining this one world supercomputer. Consensus modeling, again, coming back to agreement. If everyone is right, and everybody is always right, how do you come to an agreement? Consensus is again a very ancient science. If you look at behavioral science, if you look at military and war and Sun Tzu's Art of War and Byzantine fault tolerance, so these are all thought processes that have been brought from ancient times into a modern world on the supercomputer to ensure that everything is behaving in the way humans behave, or humans are at least familiar with behaving. Cryptography, again, is a 2,000-year-old science. It's not something new. We are using, again, an ancient science to bring security to a one world supercomputer where we feel comfortable where to transact. So these are the logics essentially that are available on the digital economy. So now when you have all these features, blockchain is essentially becoming government. It is going to be the new government. And this is the promise of blockchain, which is called the Decentralized Autonomous Organization. And I will read it out for convenience sake. A DAO or a DAC is an organization represented by rules encoded on a computer program that is transparent, controlled by shareholders, and not influenced by central authority. A DAO's financial transaction and record programs rules are maintained on a blockchain. So essentially what you're doing is you can replace country governments with a decentralized autonomous organization to, I don't know, issue birth certificates, to issue cards, to issue, to do whatever you want. I mean, even things like, so one of our projects, which our company is currently doing research on, is universal basic income. So we can actually go ahead and build a universal basic income model on a decentralized autonomous organization such as this. So this is the promise. And the whole idea of this is that it cannot be stopped. It cannot be broken. It cannot be shut down. No one has any control over it in the sense that you can stop it. Right? So we're talking about a lot of a radical concept essentially, which sounds futuristic. Probably maybe our grandkids will be the ones who will be really benefiting from this technology. But what we have to understand is that we are building on this technology today. We are starting now at grassroots level to be able to ensure that in about 10-15 years, when this phenomenon builds, we are familiar with what's going on. So let's just come back to our reality right now and try and make sense of this. So I'm sure you're all familiar with Gartner. Gartner is a research organization. Every year they release what is called a hype cycle, And a hype cycle is essentially how technology starts off and how it actually takes to become, how long it takes and what process it has to flow to become a mainstream technology, right? So if you look at blockchain, my mouse is probably not going to work, but hang on. Use this. Okay, anyway, it's not working. But if you look at where blockchain is, it's in the trough of disillusionment at this point. So how do you, so it's gone through the circle of innovation trigger, which is at the bottom. And then it moves on to the peak of inflated expectations through the trough of disillusionment. Now you can measure this very simply because the peak of inflated expectations was when cryptocurrency was going through the roof, when Bitcoin was hitting like $5,000-$6,000. And now it's coming down through a trough of disillusionment, which is a good sign for us, at least in the blockchain space, because we are hoping that we reach the plateau of productivity as soon as possible. So now we will discuss the different types of blockchains. So what is the, because it's so big that we have to sort of break it down and classify it and try to see how we can fit it into what we need, our present day use. So what you have to firstly imagine is Bitcoin. Now, please take note, the Bitcoin blockchain is always written with a capital B, and the Bitcoin cryptocurrency is always written with a small b. You need to imagine the Bitcoin as an operating system for the one world supercomputer. The cryptocurrency aspect of it we will discuss, but I want to relate one example to you. So about 15 years ago, our country in India here, we wanted to migrate from regular combustion engines in our rickshaws and move them to a more eco-friendly sort of engine, which is the LPG or CNG, which they're using right now. So what the government essentially did was the government gave them subsidy. The government gave the rickshaw guys subsidy to go ahead and do that migration from a regular diesel combustion engine into an LPG or a CNG sort of engine. So the government offered financial subsidy to change user behavior. And that is how cryptocurrency relates to the operating system. It's like a loyalty system, like how you fly, you get miles on airlines, and you get credit card points, and everyone's giving away points nowadays. So you have to imagine that the cryptocurrency is the same aspect as that was of the blockchain. So it's actually motivating you to maintain the blockchain. So Bitcoin is a what they call a public blockchain. Anybody can join, as in when they feel. They can leave when they feel, and it's open to innovation. But again, we can go into that in a separate discussion, because what happens is if someone believes differently, they would have to go and download the operating system and then change it around and then make hard fork or soft fork, as they call it, and make the changes. But we will not go into that right now. So Bitcoin essentially was created by someone called Satoshi Nakamoto. We don't know who this person is. It could be a group, it could be a girl, it could be a boy, it could be anybody. We're not sure who this person is, but my personal view on this is that it's somehow by artificial intelligence being created to give us an example of how we can move forward with decentralization. So that was the initial that happened around 2010. So once the idea was out there, a lot of people jumped on this bandwagon. Okay, a lot of people jumped on the bandwagon and they wanted to explore. Now, Vitalik Buterin, if I'm sure you guys have heard of this person, he was 19 when he created Ethereum. What he basically went and did that, okay, we have a one world supercomputer, we have an operating system, we have this currency that supports the operating system. Now we need an operating system with an app store, which is what Steve Jobs did, same thing. So what he did was he created Ethereum. He downloads the Bitcoin Core application. He customizes it to include other people to come in and build applications on it. And you will keep hearing this word a lot, dApps, which is decentralized application, to come and create applications on the Ethereum operating system. Okay, so even Ethereum have their own currency, they have their own blockchain, they have their own open and closed sort of network. It depends how you want to get involved in it. And they reward people with their cryptocurrency to maintain the blockchain or the network or the supercomputer in this case. Now, Hyperledger was another interesting twist. So again, people, they said, okay, no, we need to find some way that this is too open. We need to have some closed sort of. So the analogy here, you need to understand what Hyperledger has essentially done is when we had the internet, there was also something called the intranet, which the enterprise and the governments and big corporations were using. So they were getting access to use the intranet, which is an internal sort of internet, but not have to go out into the internet. So you have to visualize Hyperledger is following the same route that they are giving enterprises a closed network to work with. So you will keep hearing these words like ecosystem coming more and more into our vocabulary, where you have Hyperledger application being used to bring in ecosystems. So a classic example of this would be, let's just say, insurance. Insurance essentially is a good use case, or let's just take healthcare. It's easier. So if you're not well and you want to go and see a doctor, you first need to check with your insurance company. Your insurance company will say, okay, you have a list of 10 doctors. You go to those doctors. The doctor will check. He said you have so and so ailment. That ailment then needs to go to the insurance company to cover it. The insurance company comes back, gives the doctor. Doctor says, okay, this is the medicines you need. Again, it goes to insurance. So there's a process there, and there is an ecosystem happening there. So what Hyperledger basically is attempting to manage is this ecosystem. So when you are sitting at home, you need to go and check with the doctor what's wrong with you. You have to go and manage that with your insurance company, with the pharmaceutical company, with your hospital, and probably charities in some countries. So what Hyperledger essentially is doing is creating smaller ecosystems within the bigger ecosystem, so you are able to manage all these processes internally. Another good example is Ripple. Ripple is not fully closed. It's also not fully open like Bitcoin, and it's essentially what we call a hybrid network. A hybrid network is you can join, but as long as you have permission. It's an interesting use case. Please go and check what they're doing. They're basically involved in clearing and settlement, and it's a very big company. I think it's valued at some crazy $1 billion right now. But Ripple basically started working on the blockchain since 2012, and they have really managed to become a very powerful company today, being able to solve the clearing and settlement problems for the banks. So again, it's an ecosystem. They're connecting all the banks together to create a fast accounting system to be able to settle the clearing and settlement problem, which usually takes up to a week. In some cases, in international small banks, can take some time before the clearing and settlement is done. But these guys are doing it very quickly. So please do go and do some research and understand what Ripple is doing. So these are the three main blockchains. So we saw Ethereum and Bitcoin on the left, which is a public blockchain. We have Ripple in the center, which is hybrid, and Hyperledger, which is private. So you have a closed sort of network where people can only join if they're invited to. Right, so now let's talk about cryptocurrencies. So like I mentioned before, cryptocurrency is essentially an incentive program to help you or to support you or to motivate you to help maintain this operating system or to help maintain this computer or to help maintain the network, right? There are many, I'm just showing a fraction of the cryptocurrencies here. There are many cryptocurrencies today. How you need to understand cryptocurrencies is essentially each cryptocurrency that was ever launched stands for a philosophy, stands for a belief system. So if you look at Monero, for instance, Monero believes in privacy, in making payments anonymously. If you look at Dash, if you look at Zcash, if you look at Litecoin, there is in fact a company even in India that is called Swatchcoin that is doing some interesting work, and they essentially pay you to sort out your garbage in such a way that it's clean and it's plastic is plastic, paper is paper, and it's ready for recycling. And each time you do that, they just hang on a second, I'm getting a question mark here. Is everything clear? Is it okay?
Yeah, slides are moving all good.
Okay, fine. Let's get back. So essentially, you have to visualize cryptocurrencies as a motivation, as a community building incentive program for you to go out there and buy hardware and learn how to use this application, how to run the operating system, and basically manage that blockchain. So Bitcoin has their own, Ethereum has their own, Monero has their own, Dash has their own, Zcash has their own. Like, so there are different types of cryptocurrencies built. All of them are essentially built on what is called the Bitcoin blockchain. You can go do that today. Go download Bitcoin Core, install it, play around with it, see how you feel comfortable, how you want to engineer this one world supercomputer for it to suit your needs. There are a lot of companies coming up with different solutions. So mining is basically the act of supporting this network. I'm not going to go into all the details of the hashing function and the SHA. We can have a separate technical session on that. But the point is that you are getting a reward to motivate you to support this. Why should you go out there, buy more RAM, buy more hard drives, buy more power to go and support this network? This is what cryptocurrency is essentially for. So now let's try to understand why would the government, which is by definition a centralized entity, support a technology or a phenomenon that is against the very essence of it. It's a paradox, which is why you have a lot of resistance from governments to actually go ahead and adopt this technology. You have governments who are just coming in and taking some very small aspects of it, like using only smart contracts or using only the hashing function. If you look at India, I think NASSCOM had released a report a couple of days ago about the top 3 use cases of blockchain in India. It's very minimal. It's like saying, I love the computer, but I only want to take the RAM. You know, that's the kind of philosophy they're applying. Not using the whole potential of this thing. So you have a lot of smaller countries, obviously, because they need to build their economy, supporting blockchain. But most of the larger countries are not really supportive, if you like, of this. But at the same time, they also understand that they need to come to this. They need to accept this technology, because if they don't accept it, people as a democracy will be bringing this up at some point in time to take over. So I'm not going to go into the details, but what essentially governments is doing is what we call divide and conquer. They break apart technology to suit themselves, to see how they can use which segment of the blockchain phenomenon and accomplish the problems or solve the problems that they are currently facing. So let's take some real life examples of how governments. Okay, so this is a classic. So India, this is all real life problems that countries are facing, right? Let's look at the first one. India is said to have electricity surplus, but power cuts might not become a thing of the past. So what does that mean? That means that we're going to have a lot of power in the country, but still it's going to be an issue in distribution. So that is a power distribution problem in the country. So you can't exactly blame the government for everything. India's a huge country with difficult terrain, and it's got its own interesting challenges. So how does blockchain help here? Imagine you have your one world supercomputer where everyone is connected with each other and everyone has certain logic, everyone has a certain currency or Bitcoin or whatever you want to call it, energy coin that they believe in. And all they have to do now is go home, install power panels or, I don't know, wind turbines or any power generation source on their roofs. And now everyone is generating power. And because you're all present on the one world supercomputer, it's very easy to transfer that power, right? So that's a classic example of how blockchain can solve problems in the real world. Fake news is a classic use case for blockchain because of a hashing function. A hashing function is essentially a method of cryptography where you give in a string and it always gives out a 256 string. I mean, we could talk about that in the next session. But what it essentially means is that if once you hash a certain piece of data, you cannot replicate it because the hashing function makes a 256 string out of it and it cannot be replicated. Healthcare, we discussed. Kolkata or Bengal rather, is essentially issuing birth certificates on the blockchain. This, again, it's not so much on the blockchain, but they are definitely using the hashing function to ensure that this one birth certificate that is issued cannot be replicated. Again, for elections is also a very interesting use case because whoever is voting, you can manage some level of privacy as well as using the immutable ledger, where you cannot really change what once has been recorded, and even if it is changed, you can tell that it's been changed. Another classic example is Putin. Putin essentially, he wants to see, the thing about Putin essentially, if he had to invest $10 billion in Bitcoin, I really don't think he'll be talking about it. But the fact of the matter is, it's out in the news, and whether it's true or not is a different discussion. But it's interesting to see how governments are actually leveraging certain technology to help them. So Russia wants to go and buy Bitcoins to transact with the global community without getting US sanctions, because they don't have to use a US dollar anymore. So these are some of the ways how the government has split apart, has divided this technology, has taken bits and pieces of it, and is actually going to use it to help themselves. So ecosystem, this is something which, like I mentioned before, will be appearing more and more. Ecosystems are present everywhere. Ecosystems are present in supply chain, they're present in government. So all government entities, they're present in healthcare, the example we discussed earlier. They're present in education, legal, food. So, I mean, we can take another example in order to save time. Maybe we can take, we discussed energy, we discussed banking, we discussed healthcare, we discussed. Let's take supply chain, for instance. Supply chain, again, is a classic blockchain use case where you have, let's just say, the car manufacturing industry, and each component of a car that is manufactured is basically manufactured by some other manufacturer. It's not like Mazda or Toyota is manufacturing everything from A to Z. So what blockchain will essentially do is create a process where each and every small player involved in the massive ecosystem is able to come onto this network and be able to securely process the flow of how an order is placed and how it's delivered and how the payment is managed. This is all being done through smart contracts. I think we'll probably do another session where we can go into a little bit detail about each industry, and we can take some feedback from you guys about which specific industry you would like to talk about, because each ecosystem is so huge, especially in the enterprise. We haven't even discussed the public blockchain yet, things like Ethereum, and so it's so big that it will actually take some time for discuss, and we just have about a few minutes left. So think about blockchain, use it in the right place. Don't think that it can solve all the problems. It can solve some problems, but it cannot solve everything. We have to optimize how it's being used. Also, another thing we have to bear in mind about blockchain is it's very new. It's maybe maximum 10 years old. I mean, you can imagine yourself when you were 10 years old, what you were doing. You know, we are not able to stand ourselves. We need our parents to help us, and so on and so forth. So it's a new technology. It has scalability problems, such as, like I mentioned before, how do you motivate, since we are all now owners of this one world supercomputer, how do you scale? How do you convince people to go out and buy more hardware? How do you convince people to install more RAM? Why should someone go out and run a major node versus a minor node? There are costs involved with it. It's an extremely expensive process, like anything else in the beginning. It's expensive. They're saying it costs a lot of money to basically set up the whole network. Storage, again, a massive problem. You're generating, you're constantly recording transactions on the one world supercomputer. So storage is going to be exponential in the coming years, at least. Education, learning curve. I don't know how many of you out there actually using things like MetaMask and JAX, and there is a different way to use these things. It's not username, passwords. There's mnemonics. There's so many different ways of using these things. So there is a learning curve attached to it, which takes time. Adaptability, usability. I mean, understanding that the architecture of a regular computer versus a blockchain computer is again different. So the simple things like if you go into a hospital and there is a nurse or a secretary sitting in the front desk entering user data, will that person have to re-enter user data onto the blockchain to make sure that it's being migrated properly, the data, or do we have to teach her how to use the new? So there is a huge usability issue as well. Integration with legacy systems is also a challenge. How do you migrate the old databases to the new databases? How do you make it blockchain compliant? How do you ensure that timestamping has been moved across correctly? There's a huge gap there. Energy consumption. To run a blockchain network, of course, they're saying it takes, I don't know, the cost of a small village in Western Europe to support the Bitcoin network today. Privacy and security. This is another big challenge with this technology, is that what you have to understand about privacy and security is that what you may consider as encryption, as your personal right to privacy, may be against the law. You can go to jail, especially in countries like America. If you are caught using strong encryption, you can go to jail. So where do you draw the line? Blockchains are built on cryptography. They're built on this technology where you are encrypting data so that it cannot be, because it's an open environment, you cannot afford to have open data. So why and how does the government approve something that they cannot monitor? Everyone knows that the government is monitoring WhatsApp, they're monitoring our phone calls, they're monitoring our email conversations. And now with the blockchain coming, everything is going to be encrypted. So how does that translate into the government? It's going to be a challenge. And all these are discussions. No one has an answer right now. It's still early. There are a lot of companies who are doing research into these areas. We ourselves are doing research into these areas. And we could also talk about each one of these items to great lengths. And I think in interest of time, we'd probably have to move on. So I'm going to end this session with this. I want you to envision birds, or envision entities being separate but together at the same time. We are all part of one big human mass consciousness, and we are somehow recreating that mass consciousness onto a machine, onto a computer, onto a one world supercomputer, where we are able to communicate with each other, transact with each other, and no one is able to stop or control or intermediate this communication or this interaction that we're having with each other. We'll jump to some questions now, because we have last 15 minutes left.
Yeah, Irfan, thank you so much for the presentation. There are the questions which you can see. So as per the relevance of the topic, please go ahead and answer a few of them.
Okay, hold on.
You want me to read them, or I mean?
I'm just trying to find the questions. Hold on. We cannot hear. What is the role of cryptocurrency in a private network? I hope that was answered.
Mm-hmm.
How we can build our own blockchain centralized version? You'd have to go and download Hyperledger. It's just quite simple. It's not rocket science. We seek to develop our own centralized blockchain as we require. Hold on, sorry guys. Oops. Okay, I cannot read some of the questions because it's sort of okay.
You want me to read them?
Yeah, I just want to increase the size of the screen. Okay.
Okay, so the first question is by Varun. He's asking blockchain with machine learning, how these both can be leveraged together. Any use cases?
Okay, so blockchain and ML is a classic. We are also working on a project we are building a lot of ML models for our own projects. So the whole idea around ML and AI and machine vision is also a big part of IoT and blockchain, basically automation. How do we feed certain data? How do we use decision making to process information? So a classic use case would be, in our case, we're building a decentralized marketplace for digital content, where we want it to be completely autonomous in terms of decision making. So we are creating our own algorithms for consensus and decision making on how to ascertain that certain content that is uploaded is not replicated, duplicated, or faked. So it depends. It depends. I mean, there are a lot of ways to use. We can take it offline, or if you can drop me an email, we can really dig deep into that.
All right, Irfan, the next question is, how true is the fact that it's secure? I read somewhere that flaws have already been discovered.
Okay, so let's just let's dig a little deep into that, right? So when you're talking about security, security on blockchain is basically all cryptography. Now, cryptography the implementation of cryptography can always be cracked depending on time and the amount of power and the computing power you have. So there is absolutely no way that you can say that any system or the blockchain system is 100% secure. It depends how you implement that security, right? So the cryptography itself does not usually get cracked, but people usually use man-in-the-middle attacks or brute force or 51 style attacks to basically break in and take over networks. So to answer your question in a nutshell, yes, they are cracking into this, but at the same time, there are people, and honestly, once quantum computing comes in, all the cryptography is going to go, all of it. So it really depends on the scenario.
Okay. The next question is about Hypermind. Like, what exact blockchain implementation has your firm done in blockchain?
So we are currently working on a project in Dubai with healthcare, and we are building our own applications for energy sharing economies. Like I mentioned before, we are also building our own application for creating a decentralized digital marketplace, which is to essentially replace Sony Music, Shutterstock, Freeaudio.org, these sort of places. It's an interesting, but again, it's a huge discussion. If you please drop me an email, I'd be happy to take it up face to face.
All right, Irfan. The next question is, what is the role of cryptocurrency in private network as it would be maintained by identified stakeholders?
Okay, so usually you don't really need cryptocurrency in centralized networks, but the reason they use it is a fast accounting system. So what you have to understand is if you are using a currency that is being moved back and forth between a centralized ecosystem, it is just if you were to actually send fiat from one country to the second country, it would take 3-4 days. But if you just send one token or one Bitcoin, or I'm not going to say Bitcoin, sorry, one centralized network token to your ecosystem, it's happening in a flash of a second. So from an accounting and management perspective, it's very fast. Now, what you would typically do in this environment, and this is also how Ripple works, they manage how and where the token is being moved internally, and then at the end of the week or the end of the month, they do a financial settlement, which money is just paid where, or any other financial settlement in terms of fiat currency is required, they settle it outside. So that's how it works.
All right. The next question is, what efforts are in to convince governments to agree and encourage the investments into blockchain, and who owns that responsibility?
Okay, there are a lot of groups which are people from our community. I mean, if you talk to a lot of people who are involved, as you know, Coin is suffering today. There were 200 people last year. Now they are down to like 10 people or something, unfortunately, because of that ATM thing they did. It is our community, as the blockchain community, that is pushing for cryptocurrency, that is giving them research papers. But unfortunately, our country is, of course, very centralized. Decision making in terms of management, as well as RBI is not happy with the Hawala system that is happening. We have genuine challenges. I'm not really sure how long this process is going to take, but believe me, there is being work done every single day. I have documents flying back and forth, governments to RBI, people working with them to make them see how they can use this technology to actually solve problems that are happening in the country.
All right. Irfan, the next question is, what is the difference between public versus private blockchain, supercomputer versus little supercomputer in terms of DLT?
In terms of what? Sorry, what is the last part?
DLT.
Distributed ledger technology. Okay. I'm not sure I understand the question. What is the difference between public versus private blockchain? Okay, so let's break it down, right? So a public versus private blockchain is what Bitcoin is to, or what Ethereum is to Hyperledger. A public blockchain is anybody in the world, including you, including me, including Ankita, including everybody, everywhere, can just buy a piece of computer and plug into the network. This is a public blockchain. You're on it. A private blockchain is you are only allowed to join by a centralized authority that is saying, okay, I accept you to join. So if we come back to our example of Ripple, you have to get Ripple's approval and the bank consortium's approval to get on the blockchain. So that's the first difference between public and private blockchains. All right. So the supercomputer is essentially an analogy for you to understand what problem the blockchain is actually doing. What is the software doing? What is it for? So that's what I wanted you to understand, that we are building a one world supercomputer, and the blockchain is essentially an application to manage that one world supercomputer. It's like the Windows or the OS X. That's what I meant. There's no little supercomputer. It's just one big supercomputer.
All right. The other question is there any site where we can see all the use cases of blockchain in healthcare?
In healthcare, I don't know about a website, but I can definitely send you some information because I'm working on a project in healthcare. I could help you with that for sure.
Sure. Thanks. The next question is, how far is the possibility to use blockchain for term loans?
For term loans?
Yep.
So fintech and blockchain go hand in hand. I think there is even one company that is offering loans. I forget the name now. I can probably dig it out. They're offering term loans on the blockchain. But again, you have to understand something, that these are very small use cases. It's just offering financial transactions in a centralized sort of environment. So it is very possible to do so when you're actually issuing a loan and the documents are received. The documents, once they're received by the applier, are hashed and they cannot be forged, they cannot be changed, and there is a consensus involved between the banks to actually issue that loan. There are several use cases of how you can actually leverage the features available on the tech to make sure that the whole issuing of the loan and the processing of the loan and the background verification of the person asking for the loan is done properly. Because it's completely transparent, you know who has approved the loan, you know where the money is coming from. So there are different ways to do that. So it is definitely a very good use case. But my view on these things is that offering loans on a blockchain is a very, very small use case. Again, it's like saying, I like the computer, but I just want the RAM. Get it?
Right. The next question is, what are the blockchain certifications available for a career perspective? Are there any blockchain certifications available, Irfan?
So my usual answer to this is yes and no. You could have a certification in blockchain but not be able to do anything. Right? The best way to learn blockchain is just download the Bitcoin core and get started. But if you really want to do a course and have a nice certificate that you can hang on your wall, if you have the money and time, go to MIT in the US. If you don't have the money and time, you can also go to Kerala Blockchain Academy, which is I have some friends working there. I know they're doing a pretty good job. There are also a couple of institutes in Hyderabad that I can share some names with you who are actually doing something. I think even IIT now has blockchain certification. But the thing is, it's such a new technology that I really don't see how people are giving out certificates. I mean, you're going to learn and do what? It's changing every day. Every day there's a new blockchain. Everyone's coming out with their own knowledge, ZK proof, with their own cryptography, with their own. So it's evolving in such a fast manner that by the time you start your course and end it, you're already outdated. You get it. So yeah, it's nice to have a certificate, but I think it's better to just be hands-on and do something about it.
All right, very well answered. What are the prerequisites to learn blockchain, and what are the other essential elements that we should learn in order to work? I think the same question, the one which I guess you've answered.
We can talk about this for a second. That's actually a valid question, because the whole idea of this one world supercomputer is that you are now digitizing. You are digitizing economies, right? So it helps to have a multidisciplinary sort of worldview on security. So cryptography, be nice for you to know. Economics, to understand how to create value for your currency once you've launched it. It would be interesting. Of course, it all runs on the IP layer. So it has its own set of protocols, but you would still need basic. So there is a level of technical proficiency also required in terms of understanding how truffle works, understanding how all these new elements, how Polkadot works, what are sidechains. There is a huge list, and I can share that with you if you just drop me an email, and we can take it offline.
All right. Seems, Irfan, there's so many questions coming up. We might even have to take a workshop out here, probably in one of the geography, like from 9 to 5, to have so many things, because I think the time was really less, 60 minutes. So
Okay.
this could also one of the option. So the next question is, which blockchain platform is more popular and matured, Ethereum, Hyperledger, or Corda? Was there anything else?
Okay, so let's be clear, right? So Ethereum is a public blockchain, Hyperledger is a private blockchain, and Corda is not a blockchain. Okay, so what you would it's like asking which is the best car, right? I mean, it depends what you want. If you're looking to build applications for public use, I would suggest you probably go to Ethereum because they're a well-funded company. They have good support from the economy. If you're looking for something fast, you have something called EOS. EOS is a Lightning Network. So you have a lot of other blockchains that are coming up where you can build applications on them. Again, the Hyperledger is essentially for enterprise use. It's not for public use. If you're building an application for banks or for big shipping companies or for big enterprise ecosystems, then that's where you would use. Corda essentially is a distributed ledger. It's very good for financial use cases, distributed financial use cases. But again, it depends what you want to achieve, and you have to find the right tool for it.
All right. Looking at the time, Irfan, let's have this as the last question. And to all of you who all are listening to this session, please give us your feedback. We are open to this. Was an introductory session. We'll have the episodes, the other ones, the future ones, as per your recommendations. Plus, as I just said, we might have a workshop in one or two geographies. So we are just open to all of you for your suggestions for a better learning. So Irfan, the last question is, blockchain is considered unhackable. However, there was a news few days back that a particular blockchain was indeed hacked. What efforts are being taken to strengthen the trust on blockchain as a technology?
Okay, so let's just break that down a little bit, right? So there is no such thing as unhackable. Firstly, this thing does not exist. Everything is hackable, depending on how much processing power and how much time you are given. So that's let's be clear on that. Second, cryptography, which is the basis of all blockchains, of how data is managed on blockchains. Whether it's RSA, whether it's any new cipher or whatever level of cryptography you're talking today, can eventually be cracked by quantum computing once we have that kind of processing power, which can be cracked. So what essentially is being done is when you have, so if you look at Bitcoin, you look at Bitcoin Cash, you look at Bitcoin Lite, blah, blah, you have a lot of people who are bringing out their own version of the blockchain and then creating their own custom cryptography and security levels on it. Okay, so to answer your question in a nutshell, even you can go in today, download the Bitcoin Core, make your own changes to it, add your own level of cryptography, add your own level of security, and make sure that doesn't get cracked. But fact of the matter is, all cryptography will be cracked. All systems, if it's hackable, it will be hacked. I think even Ethereum, the old original Ethereum Cash was also had undergone a 51% attack, where because it's a decentralized environment and not one person can own it, you need to ensure that you have maliciously taken over 51% of the nodes in the network to be able to create decisions and then hack that network. So there are different ways of actually going about and breaking the system to be able to get what you want. I hope that's answered your question.
Yeah, absolutely. Thank you so much, Irfan, for your time and efforts and for curating such an interesting session. And we will be back with him again by the mid of May. There will be another episode by Irfan. So stay tuned. And for the other session, which is coming up, it is on 24th of April from the product management series. And the topic is product stories by product managers. So for more information, just visit nasscom.in/events and register for the next session. And please write your feedback, suggestions. We are open for it, and better learning again, in our next episode. Thank you so much, Irfan.
Okay, take care, guys. Talk to you next time. Bye.
Bye. Bye.